In this part, we will learn the difference between the discrete and continuous exponential growth. See, both are exponential growths, right? The only difference is that their style of growing is different. So to understand their style, let's create a situation and understand that situation first. Suppose you deposit $1 in the bank and bank says, I'll give you 100% interest per year, right? Okay, 100% interest per year. Now, and the bank says, okay, that will be compounded annually. When it says compounded annually, that means you are going to interest only once in an year. So that will be 100%, and that is known as compounded yearly, okay, or compounded yearly. So our formula is A of t, that means amount after time t is equal to initial amount 1 plus r raised to power t. Now amount after 1 year, when it is compounded yearly, it is initial amount 1 plus 100% is 100 upon 100, which is 1 raised to power. You are going to get interest once in a year. This is that one. That means $2. Initially it is $1, right? Okay, that is the formula. So initially it is $1. After 1 year, you get $2. But if bank says that I'll give you interest 2 times in a year, so that is known as compounded half yearly. That means after every 6 months. So what happens in this case? Definitely in 1 year, because you are getting interest twice, the rate of interest will be half. So it is 50%. That means 1 by 2, and you are going to get interest 2 times in a year. So that is why it is here 2. And if you calculate it, this is $2.25. So more than this. Now what if you get interest 4 times in a year? So words will be compounded quarterly, right? So that means in 1 year, because it's happening 4 times, rate of interest will be 1/4, and you will get interest 4 times in a year. And if you calculate this, this is $2.44. Okay. Now what if you get it every month? That means compounded monthly. Compounded monthly. Compounded monthly means every month, whatever the interest is, that will be deposited into your account monthly. Because you are getting interest 12 times in a year, rate of interest will be 1/12, and number of times will be 12. Now if you calculate this, this is $2.61 years. What if it is compounded daily? See, more times it is compounded, you are in benefit. So this is really real life situation, compounded daily. So that means in 1 year, rate of interest will be this much, and you are going to get it 365 times. That means $2.71. Now what if it is compounded every second, every fraction of second, right? Infinitely. Infinitely. That means continuous. That is $2.718 or maximum, right? It is infinite. So that means it is growing every second, every fraction of second. It's like this. Now, if I say compounded yearly, that means for 1 complete year, your amount is not changing at all. But after 1 year, you get a hike. Then again, it is still for a year. then it is a little bit more than that. Then again for 1 year, and it's more than that. So that means it's happening at stages, not continuous. No doubt, if we just draw the graph, it's like this, but it's happening in stages, right? So this is the difference between continuous and discrete growth. So if we go with the formulas, the formula is for discrete growth, a t is equal to a 1 plus r. If it is compounded yearly, then you can see I am dividing it by that number, and that number is multiplied here with t, right? But if it is continuous, right? So in that case, this special number 2.718 is actually e. So here growth factor becomes e, or right? Am I right? Yes. So our formula is amount is equal to principal e raised to power rt. So that is the formula for continuous growth, right? Okay, when it says bacteria doubles or triples, then we say y is equal to ab to the power x. Y is actually the amount, right? ab to the power x. Now we will solve a question where we are going to use these formulas. $5,000 are deposited in an account earning 7% interest. Okay. Calculate the final amount in the account after 6 years. So this 7% interest is yearly, right? This is yearly. Yearly interest is whenever no word is given, it's kind of yearly. Okay. Compounded monthly. Compounded monthly. That means if it is 7% interest, right? So 7 by 12, 7% by 12, it will be divided by 12 rate of interest, because you are getting it 12 times in an year. So our formula will be, okay, for A, our formula will be amount is equal to principal 1 plus R upon M T. So amount is equal to, principal amount is 5,000, 1 plus, because it's 7%, and that will be divided by 12, because you are going to get interest 12 times in a year. So 12 times. Now this is for 1 year, right? 12, and here instead of year it is 12. This is 1 year, but it's about 6 years. So that will be multiplied by 6. Okay, so that is 5,000. 1 plus decimal 07 by 12. 12 6. Okay, use the calculator. That is $7,600.53 compounded monthly. What if it is compounded continuously? Now our formula will be amount is equal to principal. This is the growth factor, r to the power t. So 500 is, 5,000 is initial amount. E, 7% is the rate of interest, times 6. Here it is applied once, because E has already, taken everything into account. E has taken everything. Okay. So, okay. This is 7609.53. No, sorry, 81 cents. See, it's more than this. Okay. What about third option? How long? How long? Now time is asked. It will take for the amount to double. Okay. So one thing is missing here. Let's take it like, if it is compounded monthly, how long will it take to take the for the account to double if it is compounded monthly. Okay, so that means amount is double. Part C, double amount is $10,000 is equal to 500 e to the power, no, it's double, it's not continuous, it's double. So 1 plus decimal 07 upon 12 raised to power 12, because it is compounded monthly. Now we have to calculate this t, and when we get a variable as a power, we use the natural log. First, dividing by 5,000 on both sides. This is this is 1.00583 raised to power 12t, applying natural log on both sides. So this will become natural log of 2, this is 2, is equal to 12t natural log of 1.00583 dividing by 12, natural log of 1.00583 on both sides. We get time. So time is equal to 9.94 years. Right? I hope the difference is clear, because when we will be doing the intermediate level of questions,